On number 12, we have the same options we did on number 11. We still can't complete the square because a is not 1 and b is not even, but we can factor, use the quadratic formula, or use our graphing calculator. So again, I'm going to show you factoring and using your calculator. This is only two terms, and so remember, two terms we can only factor if the two terms have a common factor you can factor out, but there's not anything that divides into 25x squared and into 4. So the only way that's going to factor is if it's a difference of two squares. Well, it's a difference because we have subtraction there, and 25x squared and 4 are both perfect squares. So remember, to do this, you're going to take the square root of 25x squared and 4. 25, when you take the square root of it, is coming out as a 5, because 5 times 5 is 25. And remember, even exponents, you take half of that exponent. So the square root of x squared is just x. The square root of 4 is 2, since 2 times 2 is 4. So once you've taken the square root of those perfect squares, your binomial factors are going to be the sum and the difference of these two answers. Meaning one time you're going to add them, 5x plus 2, and the second time you're going to subtract, 5x minus 2. So these are my binomial factors, and it's still equal to 0. And just like on number 11, we're wanting to know what value of x would make this binomial 0. Well, it's not quite as easy as on number 11, where we could just see it's the opposite of this number, because now that x has a number in front. But if we kind of treat it like we did with bottoms up, I'm going to get that x by itself by moving that 5 back underneath the 2 and make it as a fraction, x plus 2/5. So you can see if I did the bottoms up, I'd get back to the 5x plus 2. Same thing here. I'm going to move that 5 underneath that negative 2 and write that as x minus 2/5. So now I can find my solution very easily. In order to know what would make this binomial 0, x needs to be the opposite of a positive 2/5. So x would equal negative 2/5. Same thing here. The opposite of negative 2/5 is a positive 2/5. And so those are my solutions. Now I could do that on my graphing calculator the same way I did number 11. Go to my y equals and change that quadratic to number 12, 25x squared minus 4. I'm still going to leave y equals 0 and find the points of intersection. We can see by looking at the graph that there are again 2 of them. And so to find them, I'm going to go to the calc menu, second trace, number 5, press enter 3 times. The first solution is 0.4, which is exactly the same thing as 2/5. It's just in decimal form. So those are the same solution. To find the other one, I'm going to hit second trace 5, move my cursor closer to the other one, press enter 3 times, and I get negative 0.4, which is the same thing as negative 2/5. So we get the same solution whether we use our graphing calculator or we factor on these two.